In this lesson today, we're looking at division. In particular, we'll be going through the division algorithm. We'll focus just on the short division algorithm, so it should be nice and quick. And then we'll look at some mental strategies for division as well. So starting with the algorithm, I've written it down in advance so we can kind of step through it together. Now, the algorithm for division is pretty straightforward. Now, I'll go through a question. Let's say we've got 597 and we're dividing by 4. So we'll go through and we'll kind of highlight out the process. So 597 and our divisor is 4. The first step is, in the algorithm, divide the leading digit. So that's that first number. So we'll take that first number and we'll divide it by 4. So 5 divided by 4 is 1 with a remainder of 1. So 4 times 1 is 4. We can't do 4 times 2, it's bigger than 5. So the idea here is how many times can 4 go into 5? And the answer is 1, and there's a remainder of 1. So what I like to do in this situation is cross out that, knowing that I've used it, and that remainder goes on to the next one. So now we've got 19 as our new leading digit. Right, so we now repeat the process again. So that's all we've basically done. We've divided by the leading digit. We wrote the answer at the top. We worked out the remainder and combined it with the next digit. That's at 19. And then finally, we cross out the used column and start again with a new leading digit, which is 19. All right, so 19 divided by 4. 4 can go into 19 4 times, so it goes up to 16, and there's 3 left over. So 4 here, we've used 16, and that means there's 3 left over, and our new leading digit is 37. Now 37 divided by 4, so 4 times 9 is 36, so we can go in 9 times, and we've got 1 left over. So because we've run out of room here, there's a few different options. We can go decimals, we can go whatever. I'm just going to go remainder. So remainder is 1. We've got 1 left over. So writing an answer here is an important thing. We don't want to write remainder 1. That's what we used to do. And we can write a fraction answer. So if I look at 597 and I divide it by 4, my answer is this 149. So sometimes we call that the quotient, the answer. So our answer is 149. And instead of writing remainder 1, we can write plus 1 out of 4. So we've got a remainder of 1 and we're dividing by 4. So that gives us our fraction answer, 1 out of 4. Now that allows us to do lots of cool little things. We could say that is 149.25. We could write it with a remainder. We can write it with that fraction. I'm happy with the fraction for the answer. Okay. Hopefully that makes sense. I'll go through a couple more and then I'll get you to pause and do a few for yourself. So our first one is we've got 1,327. So 1,327 divided by 4. All right. 1 divided by 4. Not possible, right? So that means we've got a 0 here. And that 1 is left over, so it carries on to the next one. And we've got 13. 13 divided by 4. So 4 goes into 13 3 times, goes up to 12. So we've got 3 times. And we've used 12 here. So that means we've got 1 left over, a remainder of 1. We carry that on. Now we've got 12. 12 divided by 4 is a nice even 3. There's no remainder, so we don't have to carry anything. And then finally, 7 divided by 4 is 1, and there's 3 left over. So that means our answer is 331 and 3 out of 4. So remember, remainder 3 out of 4. So we could, if we wanted to, write that as a decimal because 3 out of 4 is 0.75. We could say that's 331.75. Okay, next one, 563. So 563 divided by 5. Right, so first one, 5 divided by 5. is 1. There's nothing left over, so we can just forget about it. Now 6 divided by 5. 5 goes into 6 one time, and there's a remainder of 1. There's 1 left over. And then finally, 13 divided by 5. It goes in twice, so it goes up to 10. And there's 3 left over, so we end up with a remainder of 3. So nice and easy. We now have 112, and we've got 3. So we've got a remainder of 3 out of our divisor 5. So 3 out of 5. Now, if you know your decimal conversions, 3 divided by 5 is 0.6. So we could write it as 112.6. Now, I will point out really quick, I'm absolutely happy with this. So if you leave your answer as 112 plus 3 out of 5, then I'm super happy. If you can turn it to a decimal, that's even better, but I don't mind which approach you take. All right, last example, we've got 8, 6, 4, 2, and we're dividing by 11. All right, so how many times does 11 go into 8? Answer is none. And we can carry that 8. So now we've got 86. All right, so how many times does 11 go into 86? So the biggest one it goes into is 77, right? So that means we've got 7 times, and if it goes up to 77, we've got 9 left over. So we've got 9, 4. Right, how many times does 11 go into 94? So it goes into 88, so that means 8 times. Goes into 88, and there is 6 left over. And our last one, 62, it will go up into 55, so that's 5 times, and that gives us a remainder of 7. So our answer will be that it's 785, and we've got a remainder 7 with a divisor of 11, so and 7 out of 11. Now, I'm not expecting you to know that decimal conversion, so let's just leave our answer like that. All right, so hopefully that's happy days. Hopefully you remember that process, that algorithm. Now, if you're one of those people that does long division, I'm one of you as well, then feel free to use long division. Short division works as well. Remember, the whole idea is that we're trying to accurately go through a process as competently as possible. And in the end, the only time you'll need long division is if you go into high-level mathematics in grade 10 and 11 and you're doing something called polynomial division. But that's a long way in the future. So now I want you to pause, and I've got 2 questions for you to do. When you finish those 2 questions, unpause, and we can continue moving forwards. Okay, so you've finished the 2 questions. The first one, we're looking at 723 divided by 5. 5 goes into 7 once, and we've got 2 left over. 5 goes into 22 4 times, and we've got 2 left over. 5 goes into 23 4 times, and we've got 3 left over, so we've got a remainder of 3. That gives us 144 and 3 out of 5, or if we know that 3 out of 5 is 0.6, it's 144.6. Okay, second one. 1240 divided by 6. Well, 6 goes into 1 0 times, and we can carry that 1. 6 goes into 12 twice, and there's nothing left over, so nothing to carry. 6 goes into 4 0 times, and we'll carry the whole 4. And 6 goes into 46 times, so it goes up to 36. And that means we've got 4 left over. And this gives us 206 and 4 out of 6 remaining. Right, we could write that as approximately 206 point, so that's 2/3, so 0.6 reoccurring. Now, because I've put the reoccurring on, that's not really approximately, so let's use our straight equals. Okay, So that's the division algorithm. You may or may not be wonderful at it, and the only thing you can do from there is practice. I should point out as well that obviously, just like the multiplication lesson, it comes down to you knowing your times tables. So division is easy if you think about your times tables and go, okay, how many times can 6 go into 40? If you know your times tables, you know that 6 times 6 is 36, and we're good. If you don't know your times tables, then it's a much longer process. There's a lot of counting in sixes and trying to work out where we get to. All right, so now we're going to look at mental strategies, and I'm just going to focus on 2. These are my 2 favorites. So mental strategies, we want to use multiplication and remainders, and the second one, we can look at a fraction form if it's a big one. So using multiplication and remainders is basically we want to use our times tables or counting in certain values to work out how many times a number can go into another number. And then hopefully we can also identify remainders, which are those leftover values. Now, I really like this strategy because it's pretty quick, particularly if you're able to use these strategies reversing multiplication. So let's look at a really simple example. Let's look at 97 divided by 5. Now, if we can work out how many 5s go into a number that's close to 97, then we're pretty good from here. So here it'd be thinking, okay, so 5 times what? And it's either going to be 100 that we're looking at or 95. So knowing at divisibility facts, we know that 5s can only end with 5s and 0s. So aiming for 95 as that highest multiple that's less than 97 is a goal. All right, you may not know this, but you can count through. We know that 10 times 5 is 50, and hopefully we know that 20 times 5 is 100, so it's going to be 1 less than that. So we're thinking 5 times 19 is 95. And that means that this division then is going to give us 19, and we'll have a remainder of 2, or better yet, we can say that's 19 and 2/5. So the remainder of 2, and we're dividing by 5. So that strategy really is like the algorithm, but it's a bit of a shortcut, so we don't have to do each of those values individually. All right, let's look at one more example. Let's say 137 divided by 20. So it's the same idea. Because we're dividing by 20, we want to flip it back around and go 20 multiplied by something is equal to. Now, the equal to, if we count in 20s, we go 20, 40, 60, 80, 100, 120, 140. 140 is too big, so we want to go back to 120. So 20 times something is 120. That ends up being 20 times 6 is 120. So that means we know that if we divide 137 by 20, we can go in 6 whole times. So the answer is 6. And we've got 17 left over. So I suppose we could write that as 6 remainder 17, or we could write that as 6 and 17 out of 20. Okay, so I like that one. That approach is probably the one that most people will use. Now, the other side is maybe a more complex version, but it is useful when we try to simplify. So the other day in class, I asked you, and it was during the mentals, we got to 400 divided by 20. And we got all sorts of crazy answers. So my thoughts in questions like this, when we've got 2 big numbers and we can see that there's common factors or numbers that we can divide them both by, it makes it much easier to write them as a fraction. So 400 divided by 20 is the same as the fraction 400 over 20. Now in this case, the idea should be, is there something that we can divide both of these values by and get whole number answers? So I'm hoping that you can see straight away I could go, oh, wait, I could divide 400 by 10. That's an easy one. And I can divide 20 by 10. That's an easy one. And really what we're doing is we're just getting rid of those zeros. So that becomes 40 on 2, which of course is the same as 40 divided by 2. And we turn something that we initially found hard or looked hard into an easy divide. Okay, so 40 divided by 2 is just 20, and we're happy. Right, so fraction form is a really good strategy. It's actually the strategy that I use a lot of the time. I kind of use a mix of these two strategies depending on the scenario. So let's look at another example. Let's say we're looking at 250 and we're dividing by 12. So I don't know about you, but trying to work out how many times 12 goes into 250 can be a little bit challenging. So if we write that as a fraction, is there any values that we can divide them both by? And because they're both even, the easiest thing is to go, well, actually, I can divide them both by 2. So that becomes 125 divided by 6. So now instead of having to divide by 12, we can divide by 6, and that might be a darn sight easier. So if we employ our using multiplication strategy, 6 times something is equal to, if we think about 10 times 6, we know that 10 times 6 is 60. And if we've got 2 lots of 60, we get 120. So we're aiming for 120, I think. That means 6 times 20 is 120. And that means our problem over here would be, we've got 125 divided by 6. It goes in 20 times exactly, and then we've got 5 left over, so remainder 5. So 20 and 5 over. So I think that that's probably enough. We've looked at the algorithm, and hopefully you're pretty confident with the short division. If worse comes to worse and you have trouble with these mental strategies, then at least that short division algorithm is a pretty quick one to do. All right, so I've set some questions. These are the questions here. Basically, I want you to work your way through. So mental strategies, using times tables, using mental strategies, and then I also want you to do the short division algorithm. So I want you to do question 1, 2, 3, 4, and 6. That'll be in the Spiritus lesson as well. Just paste it in below. Okay, so make sure you check your answers. And if you're finding them easy, you can have a go at 8, 9, and 11 as well. Okay, thank you very much.